Support tickets aren't hard because they're technical. They're hard because they're messy. So I started wondering, could we build a support inbox that actually thinks? One that can read the angry rants, the weird bug reports, even the coffee machine failures, and sort them out automatically. That idea turned into a MongoDB talk I gave at MongoDB.local in New York. And in this video, I want to share that with you too. The slides, the demo, the whole thing. How we built SeaSupport, a reference app for support ticket data using MongoDB, DigitalOcean's gradient AI platform, and Ruby on Rails. Let's go. Hi friends, my name is Amit Jotwani. This talk is called Triage Without Tears. And in this talk, I'm going to walk you through how I built a reference app that takes messy support ticket data, runs it through MongoDB and DigitalOcean's gradient AI platform, and turns it into something that's much easier to handle. But the cool part is that this system is not just about support tickets. The same pattern works everywhere you've got messy, unstructured data that needs some sort of analysis and filtering and a little bit of intelligence using AI. Think bug reports, IT requests, sales leads, you name it. And the best part is you can spin this up quickly on DigitalOcean without spending a ton of money or buying any extra software. Again, my name is Amit. I'm a developer advocate at DigitalOcean. I've been in DevRel for over 10 years, previously at places like Amazon Alexa and Retool. I love making complex things simple. I'm based out of New York, and I am a self-proclaimed Lego nerd and a compulsive Seinfeld coder. And I'm glad you asked. So naturally, my favorite Lego build is this on the show about nothing. But I don't work at Lego, I work here at DigitalOcean. Same idea though, simple blocks, build whatever you want. It just happens to be in the cloud. Now, if you're not familiar, we're a cloud provider. You might have read one of our technical tutorials floating around the internet, or maybe you've seen one of our one-click WordPress installs. But we do a lot more than that. We are a cloud built for simplicity with a great developer experience. We're the largest cloud by customer accounts. We have 17 data centers around the world. But what makes us really different is simplicity that scales. And all of this with predictable costs and no gotchas. And it usually costs about 30% less than the big clouds. We provide all the core building blocks, compute, storage, databases, including MongoDB, Kubernetes, and all the other tools you might need to build and ship fast without needing a DevOps team. And on top of that, we've added Gradient AI. Now, I know this slide looks busy, but here's a simple version. At the bottom, DigitalOcean gives you the basics: CPUs, GPUs, storage, networking. You don't need to set any of that up. It's just handled for you. On top of that is the fun part, the platform. You can run inference with models like OpenAI, Anthropic, Llama, DeepSeek. No hosting required for any of this. And then you can spin up your own agents trained on your docs. And those agents can even call out to external tools when they need to. So with DigitalOcean, you can not only host your app, but you can also plug in an AI layer without buying any extra software or managing a ton of infrastructure. And that's exactly what I used with MongoDB to build this demo. All right, meet Mood Brew, our imaginary futuristic coffee machine. It's got face recognition, it remembers your usual, and it even tries to guess your mood to suggest a blend. It's pretty fancy. But of course, sometimes it breaks in very human ways, which means quirky, messy support tickets roll into the Mood Brew support crew every day. And here are the stars of our story, our typical customers. We've got Angry Mike, Technical Jennifer, Forgetful Carol, and Curious Fred. And each of these people file their tickets in their own unique way, from all cap rants to forgotten passwords to very detailed error codes. And that's the heart of the challenge with building something like this. Mood Brew remembers your usual order, but in support, there is no such thing as a usual ticket. Every request looks different, and that's why they need to be handled very differently. And the real problem is that support tickets don't fit neatly into rows and columns. One could be a long emotional rant, the next one could be a terse one-liner. Some can have screenshots, others have nothing. And generic AI tools can help summarize them. But without product-specific context, they miss the mark. So if you're on the Mood Brew support team, here's what lands in your inbox. You've got Angry Mike yelling about refunds. Jennifer is pretty technical and is giving us exact error codes. Carol forgot her password again. And Fred is asking for a hangover mode, which I have to admit is a pretty useful feature. Now, these are messy, inconsistent, and not really fun to triage manually. And that's where SeaSupport comes in. It's a reference app we built to show how you can take tickets like these, store them as flexible MongoDB documents, run them through Gradient AI agent to enrich classify and tag them, and then let humans always stay in the loop for the final call. Because it's not about replacing support teams, it's about giving them some extra leverage so they can go at it faster. And let's look at the architecture. SeaSupport runs on Ruby on Rails 8 with Sidekick for background jobs. Tickets and AI metadata live in MongoDB. Gradient AI powers the analysis and the responses of those tickets. And it's all deployed on DigitalOcean Lab platform with spaces being used for file storage. Now let me show you SeaSupport in action. Okay, so here's SeaSupport in action. Your list of all the tickets that are available. I'm going to click on one of them and then click on the Q AI analysis button to analyze this ticket. It gets added as a background job. And behind the scenes, DigitalOcean's Gradient AI is analyzing that ticket. Once that is done, we will see the status completed. And we can click on View with the confidence score shown, and then I can look at the request data that was sent to Gradient and the exact response data that was received with the analysis. All of the console logs are also kept track of, and all of this data is stored in MongoDB, which is super handy given that flexible document. And then the AI analysis with confidence scores, the knowledge sources that it sourced from, and a response is also drafted that I can look at the citations and click send response to send the response. And then back in the main tickets view, that ticket is updated and I can click analyze all to add all of the existing tickets as a batch job without blocking the UI. When all of these tickets are processed, this is the view that the customer support agent will see when they log in. All of the tickets have been tagged properly so they know exactly what they should be focusing on. So as you saw, no two tickets are the same, and that's the whole point. With Gradient AI doing the analysis, each ticket was treated differently, the way it should be, so support agents can move fast and respond with confidence. Angry Mike's outage got flagged as urgent with a refund draft, Carol's login issue was auto-resolved, and Jennifer's error code was tagged as likely hardware fault, and the warranty steps were suggested to her. And finally, Fred's feature request is routed low. Now let's look at the ingredients for C nodes. And the first ingredient, of course, is MongoDB. Now, why MongoDB wins in this use case is because support tickets don't stand still. They are evolving. One day it was just the subject plus description of the ticket, but the next we added some AI metadata, tags, confidence scores. With SQL, that means migrations and joins across tables. But with MongoDB, it's just one document that just grows with you, everything in one place. Now, you probably already know this, so I'll just give you the quick visual. In SQL, here's how it might look. You have the tickets table, you have the customers table, AI analysis table, and the messages table. It works, but you're splitting one ticket across multiple tables. And if you want the full picture, you're joining multiple tables. And if you want to add a new field, you're running migrations for them. But in MongoDB, it's just one document. Customer info, AI metadata, activity log, everything's together. And if you want to add new fields, you can do that whenever you need to. There's no joins, no migrations, and that kind of flexibility is why it works so well for messy and unstructured data like this. And spinning up a MongoDB database on DigitalOcean is ridiculously easy. It's just a couple of clicks and you've got a fully managed production ready database. There's no servers to configure, no scaling headaches. You just plug it into your app and you're ready to go. And once it's created, you just grab the connection string, drop it into your app config, and that's it. And the second ingredient is, of course, DigitalOcean's Gradient AI, which does all of the analysis and the thinking. While MongoDB gives us flexible storage, Gradient is really the brain. You feed it your docs. These could be troubleshooting guides, warranty policies, error codes, which is what we did in the case of Moodbrew. It uses that as context when it drafts those responses. So the answers are always grounded in your own knowledge base. And it's not just Q&A. Agents can call external tools, use different models from OpenAI, Anthropic, Llama, DeepSeek, and all of them run with your app without you hosting any of these models. And spinning up an agent is also just a couple of clicks. You upload your docs as a knowledge base. You can manually upload the files or provide the URL for crawling. You can also point to a Spaces bucket or an AWS S3 bucket. And then you choose a model from OpenAI to Anthropic, DeepSeek, Llama, and several others. You can also experiment with the agent in your playground and tweak them until you're satisfied with the results. When you're done, you grab the endpoint and the access key for your app. And this is how it looks in Rails. Just point the OpenAI Ruby client at your agent endpoint and you're good to go. Now, here's how it all fits together. First, a ticket arrives. Rails stores it in MongoDB as a raw document, which may look something like this. When you hit the AI analysis button, Sidekick queues it up as a background job to analyze it, so nothing blocks the UI. The support agent sees the status updates like queued and processing right away. And behind the scenes, the gradient agent classifies it, summarizes, and suggests a response, and also adds a confidence score to the ticket. That enriched analysis with all of the tagging and the sentiment is written back into the same document. Tags, sentiment, confidence, suggested response, all of that all in one place in one single document. And finally, the support agents see the tickets highlighted with confidence and priority, so they know exactly what to handle first. The human is still in the loop, but you can automate more if you want. For example, auto resolve anything that's above 90% of confidence. And none of this is a black box. Every request and response is logged in MongoDB. Gradient also gives you observability. So traces, latency, token counts, you have access to all of that. And with evals, you can test your agent on real tickets before rolling out. But the real takeaway isn't just that, hey, AI can help with support. It's that you can build a working prototype like this with MongoDB and Gradient on DigitalOcean very quickly, flexibly, and without buying any extra software. And like I said, the same pattern applies way beyond support to bug reports, sales leads, IT help desk, community Q&A. And that's why we built SeaSupport and open sourced it. It's available on GitHub. It's built with MongoDB, DigitalOcean's Gradient AI, Ruby on Rails 8, Hotwire, and Tailwind CSS. So you can grab it, play around with it, and let us know what you build with it. And that's SeaSupport, a reference app you can learn from and adapt to your own use cases, especially where the data is messy, unstructured, and where you can use a little bit of intelligence applied to it. The full code is on GitHub, linked below. We would love to hear how you put it to work. And if this was helpful, please hit subscribe, and I'll see you on the next one.